All right, Unit 3, Lesson 2, Introduction to Quadratics, the Parabola. So I'm going to introduce to you this new shape, new kind of graph. It's called the basic parabola. And the equation for the parabola is y equals x squared. So what you may have been used to before with just an x now has an exponent of 2. Okay. Now, if I were to write a table of values for this equation, it would look something like this. So for x equals -3, you substitute that -3 for your x and you square it to get your y value. So -3 squared is equal to -3 times -3, which is +9. Then -2 squared, which is equal to -2 times -2, which is +4. And then -1 squared is equal to -1 times -1, which is +1. 0 squared, 0 times 0 is 0. And then 1 squared, which is 1. 2 squared, which is 2, 4. And 3 squared, which is 3 times 3, which is 9. Okay. Now, if you remember your finite differences from grade 9, well, you would look at the difference between the two consecutive y values. So if I did 4 minus 9, you would get -5. 1 minus 4 would be -3. 0 minus 1 is -1. 1 minus 0 is 1. And 4 minus 1 is 3. And 9 minus 4 is 5. And you would notice that the first differences are not the same. So for sure, absolutely, this is not a linear relation. This is not a line. But if you look at something called the second differences, and now the second differences are the differences of the first differences, and that might sound like a mouthful, but it's very simple. You take the -1 and you subtract -3. And you get +2 as your answer. Then you do 1 minus -1, which is also +2. 3 minus 1, which is equal to +2. And 5 minus 3, which is equal to +2. And you'll notice that the second differences are all the same. And when that happens, you have what we call a quadratic, a parabola. Okay? What does this graph look like? Well, here is the shape of a parabola. So if I plot those points 0, 0, 1, 1, 2, comma 4, and then 3, comma 9. And on the left side, we have -1 and +1, -2 and +4, -3 and +9. You're going to get this shape that we call a parabola. It's a smooth curved shape, and there we go. Okay, kind of like one of the McDonald's arches upside down, right? It's just it's like it's called a parabola, parabolic shape. Okay, so we can tell the relation is what we call it. So this is a quadratic relation. Okay, we can tell it's a quadratic from its table of values if the second differences are all equal. If the second differences are all equal, or you can say constant. Okay, parabolas, so the shape of a parabola, these are the graphs of a quadratic relation. So the kind of branch of mathematics we're talking about is quadratics. They are type of relations, and the shape of the graph is what we call a parabola. The point at the bottom of the parabola, so if you look at the parabola, there's a point here where the graph changes direction. That point down at the bottom, we call that the vertex. And we also call this point, when you look at this particular parabola, different parabolas will be different, but this one here, if you look at the parabola, it goes from left to right, it goes down, 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 down until it reaches the vertex. But that vertex point is also what we call a minimum point. Okay, it doesn't go any further below 0, and then it goes back up in the other direction. So that is called a minimum point. So the minimum point, the point This point is a minimum value, and we say that the parabola opens up. So when you have the minimum, the parabola opens up. You think of the parabola like like an open mouth. The mouth is pointing up. Okay, the axis. So this parabola also has something called the axis of symmetry. And this axis of symmetry always goes through the vertex. So let's draw this in here. So I'm going to draw kind of use a dotted line like this to denote the axis of symmetry. It's not a real line on that's part of my graph. It's just a axis of symmetry. And you may recall from elementary school when you have like a symmetrical line, everything on the left side of the line is a mirror image on the right side of the symmetry line. Okay, and that's exactly what it's doing here. This axis of symmetry divides this parabola into two equal mirrored parts of each other. Okay, and so the equation, so the axis of symmetry does have an equation. Okay, and the axis of symmetry is sometimes denoted as AOS. If you ever see me write AOS, it means axis of symmetry. And we write the equation because it's a line. It's a vertical line. You might remember how to do vertical lines. It's a vertical line is an x equals some numbers, whatever number that might be. Okay, so you might recall that this is the equation of a vertical line. Okay, and just like, so I mean, we have another couple of points here. So where the points in the parabola cross the x-axis, we call that an x-intercept. And where the points cross the y-axis, we call that a y-intercept. Okay, and that just so happens that on this parabola, the vertex is also an x-intercept and y-intercept because it crosses the x and y-axis at that point. Now, not all parabolas will be like that. Vertices, your vertices don't have to be x and y-intercepts. They could change as well. Okay, so let's look at another parabola. What does a parabola with this equation look like? So here's the equation, y equals negative x squared. So what you have to do is take your x value, negative 3, you square it, and then you put the negative, you multiply by a negative in front. So negative 3 squared is positive 9, but with the negative there, it's negative 9. Negative of negative 2 squared is negative 4. Negative of negative 1 squared is negative 1. 0 squared, no matter if you have a negative in front or not, it's still 0. And negative 1 squared is negative 1. And negative 2 in brackets squared is equal to negative 4. And then negative of 3 in brackets squared equals negative 9. Okay. How do I know how to put the negative outside of a bracket? How do I know to create a bracket? When you look at something like negative x squared, think of the exponent as operating with the base to the base that's attached to. So it's attached to x. It's not attached to negative x. If it was, then the equation would look like this, negative x squared. But the negative is not inside any bracket of any kind. So you only do the squared on the x, and then you multiply by the negative. Think of it as like a negative, invisible negative 1 in front. Now I can also do first and second differences. So negative 4 minus negative 9 is positive 5. Negative 1 minus 4 is a positive 3. 0 minus negative 1 is positive 1. Negative 1 minus 0 is negative 1. Negative 1 minus negative 4 minus negative 1 is negative 3. And negative 9 minus negative 4 is negative 5. Then if I do the second differences, second number minus the first, so 3 minus 5 is negative 2. 1 minus 3 is negative 2. Negative 1 minus 1 is negative 2. And so on and so on. You'll find that all the second differences are the same. Okay, and now if I graph this, it would look something like this. Similar as the first graph, except the y values are now negative. And here we are. See if I can draw that better. All right, there you go. So there's our parabola. It's now upside down. So how did the table value change to reflect that? Well, if you look at all the numbers become negative, and but the values themselves remain the same. So 9, 4, and 1, 0, 1, 4. And those numbers are still the same, but they just became negative. So how did the table of values change? All the numbers became negative. The number of values stayed the same. So the number values stayed the same. Okay. How did the graph change? Well, you notice the graph still has the same shape. However, all the y values are negative now. So all the y values are negative now. Okay. So same shape, all the y values are negative now. We can say the graph reflected on the y-axis, on the x-axis. Okay, it's flipped upside down. Now the point at the top of the parabola, this time it's still, this is also the vertex. Okay, this point right here, which changes direction, and that's the vertex. And it's now the maximum point. Okay, not a minimum, because minimum, there's no minimum. The parabola can keep going forever in both directions. But at the very top, the y coordinate, the y values don't go above this x-axis, so that's my maximum. So the point at the top is called the vertex, and this point is a maximum value, and this time we say the parabola opens down. Okay. So another diagram here: axis of symmetry, dotted line cuts through the vertex. This axis of symmetry cuts through the vertex. You have a graph opening up, and this one has the graph opening down. Okay. And that's the basic introduction to the parabola. And that ends this video.